Sorry, the thing must have cut me off mid-sentence. Anyway, this would have had volume of, sorry, congruent base. If this was a pyramid, just going straight up inside it, it would be 1/3 of this volume. If it was going triple, just like the last thing with the cylinder, if it was a height of 6, it would have exactly the same volume. So you could even say, yeah, this equals 1 in terms of volume, where the height would be 6. If the height was 6, these would be equal, but it's not. It's 5, so this is 6/5 as big. All right, so now on to the next thing, which is on page 513, self-test 2. Find the area and volume of a sphere with diameter 6. Okay, I'm not even going to write the diameter. I'm just going to write the radius. Radius should be 3. Area, they call it area. I think they should be consistent and call it total area, call it surface area, something like that. Anyway, the area is 4 pi r squared on these, which here is 3. So I want to square just the 3. 3 squared is 9. 9 times 4 is 36. Volume is the funny one. 4/3 pi times r cubed. R cubed is 27. A third of 27 is 9. 9 times 4. Guess what? It's 36 pi again. Yeah, that's the radius where those two things. Oops. Those two things turn out to be equal. Watch me make a bunch of mistakes all over this thing. All right, so that was that. All right, now they're starting to get a little fancy here already, and then the second one. The volume is 32/3 pi. Well, that's supposed to equal 4/3 pi r cubed. Well, the pi's cancel. The thirds cancel. Divide both sides by 4, so I get 8 equals r cubed. And of course, knowing this book, it's a nice number. I can do that in my head. Radius is 2. I needed to know radius because I want to put it in here. And that would be 2 squared is 4, so this is just 16 pi. Fair enough. All right, cylinder capped by 2 hemispheres. I'm kind of thinking it should look like this. Hemisphere lid, cylinder part, hemisphere bottom. Which, if you think about it, we're talking about volume. We don't, oh, it's shown. Wait a second. Found it. Look how good I am at drawing. It's exactly what they had. We could think of that instead as a cylinder. Take the 2 hemisphere parts off and just make a sphere. Altogether there we have 1 sphere and then this cylinder thing in the middle connecting. Okay, and they tell you this is 20, so I was just think of radius as 10. I'm supposed to find volume. Volume of this thing is area of the base times the height. Volume of this thing is 4/3 pi r cubed. Alright, so the area of the base here is pi r squared. I'm going to sneeze. Maybe not. Okay. Times 60. And this is 4/3 pi times 1,000. Well, this part's actually easier. It's 4,000 pi over 3. And this one is 100 times 60 pi. Now I could add these up in a fraction of pi. 6,000 pi is like, I need to come to denominator of 3. It's like 18,000 pi. 18 and 4 is 22,000. I like that. You could do that on the calculator too. All right, there's a lot of these in the homework and people are getting freaked out about this. When a plane passes through a sphere, it causes a cross section that looks like a circle. And we're supposed to find this area of this face right here. And this thing is just a circle, so to find it, to find its area, I need to know this radius here. And in the book, they use that as x. That is involved in a right triangle with the center of the sphere, because I know, first of all, this thing is radius of the sphere, and that is 13. And if I go straight down like that from that thing, this is what they call h in the book. And they tell you this is 12 centimeters from the, that's what this means. When they say it's 12 centimeters from the center, that's what it is. So I have a little right triangle here. If I do that Pythagorean theorem, I find out that this is 5. So really I'm trying to just find the area of a circle with radius 5. pi r squared is 25 pi. Okay. All right, one regular triangular pyramid. All right, means it's going to have a equilateral triangle at the bottom. Something like this. And it has base edge 8 and a height of 6. I have a similar one, so it's altogether smaller. It has a height of 4. So I know what K here is. K is the ratio of lengths. Here's a length in this pyramid, a length in that pyramid. K is 1.5. Great. So I could use that and figure out what happens to the side and all that stuff. Oh yeah, base. That's the first thing I'm supposed to do. Find the base edge of the smaller pyramid. I just use K for that because that's just a linear thing. So if I just take 8 divided by 1.5, I will get that. I can set that up as a straight proportion. 6 over 4 equals 8 over blah, and I can find it. I could also just do this now that I've got this ready to go. 8 divided by 1.5. I can almost do it in my head faster than I can do that. Oh, I don't like that nasty fraction. Let's say it's 16/3. Which could have found it just by doubling this stuff, of course. So that's this thing here. And that's the answer to part A. And part B, find the ratio of the total areas. Well, area ratio is going to be K squared. I don't even want to find this. I don't want to find this area. I don't want to find this area. I don't need to know the ratio. The ratio is simply that, which is 2.25. Which means this has 2.25 times as much area as that one. Okay, I just made what I call swimming pool prisms, where I have this bizarre shape as the surface of the water, and it matches, of course, the shape of the base of the pool, and it's a prism. And I made a similar one by the magic of copy-paste and resizing. Okay, so I do this to illustrate the fact that we can't actually even find this, but we know, they tell us that the area, the base area, ooh, I shouldn't say A then, I should say B. The area of this crazy base is 200, and the area of this crazy base is 32. Find the ratio of their heights. Okay. All I have to go on here is the 200 and the 32. If I took 200 divided by 32, I would be finding a ratio of areas. This is area over area. That would be a K squared type of situation. Can I reduce that fraction very nicely? 200 32ths is 25/4. That's nice. And you know why that's so nice? Because those are both square numbers, 25 over 4. So that's the answer to part A. Part B is, oh wait, that's not the answer to part. That's not the answer to part A. That's just the ratio of K squared. I'm supposed to find K in part A. K in part A is the square root of that because I'm looking for the ratio of length and the square root of 25 and the square root of 4. Great. B, what's the ratio of their volumes? Well, the ratio of their volumes would be K cubed, which is this thing I just found. It's K cubed, which isn't too bad. 5 cubed over 2 cubed. All right, now on to the actual chapter review, which is at the end of the chapter, which is on page 518. In a right prism, each blank is also an altitude. Just to see what they're talking about here, let's say we have a pentagonal prism. In a right prism, by right they mean it's standing straight up. If I drew this thing so it's actually standing straight up, there's parts of this thing that would actually mimic what an altitude is. An altitude, I mean, you usually think of height as that thing up in the center, say, especially with pyramids because it goes right to the point there. But this one, they're just saying altitude. Well, that's anything that is the sort of the length between the plane of the bases. And this thing I just highlighted here is, I would call a lateral edge. You can't say any edge because there's some edges down here that are not altitude length edges, but this edge here is a lateral edge. All right, right octagonal prisms, really hard to draw sometimes. Height is 12 and base edge is 7, and they're all the same. Lateral area is perimeter times height in a prism situation. All right, perimeter, I've got 8 of these equal sides. They're all 7, and the height is 12. So that's it. 56 times 12 is 672. Done with that one. Looks like they finally come to their senses a bit about this whole rectangular solid and which sides of the bases and the lateral area is different for each person. They just say, okay, let's just find the total area and volume. Well, volume's easy. Volume I can just do here, last step. That's just 8 times 6 times 5, which is 30 times 8, which is 240. That's not bad. But Total area, I'm going to add it up the way I have it here. I am going to do lateral area plus 2 bases. There's no reason I have to do that. I could actually say, well, it's 2 times 8 times 5, it's 2 times 5 times 6, it's 2 times 8 times 6, and add those up. But I know you're used to formulas, so this is okay. Lateral area, I'm considering my perimeter of base to be my 8 by 6 side here. So 8 plus 6 plus 8 plus 6 is 14 times 2, that's 28. Height is 5. And the way I have it sitting, if I'm going to use that as my base for this perimeter formula, I need to use the same base in the calculation over here, which is the 8 by 6 side. 28 times 5 is 140. And 48 times 2 is 96. So this is 236. All right, this one, right square prism, they're saying, when they say square prism, they mean it has a base that is a square. So if this is 9, this is also 9. Volume, and I don't know this. Volume is 891. If I'm supposed to find total area, I'm going to need to know this height. So that's supposed to equal 9 times 9 times h. I can find h pretty quickly if I just take 891 divided by 81. I'm pretty sure that's 11. So this is 11. And I need to find total area. Okay. Let's do lateral area plus 2 bases. How come I can't draw that? Plus 2 bases. It's already sitting on a nice base. We'll just leave it that way. Perimeter times height plus 2 of those bases. That's perimeter of the base is 9 plus 9 plus 9 plus 9. That's 36 times 11 plus 2 of these bases that are 81. I really don't care to do this in my head. 36 times 11 plus 2 times 81. It's 558. Great. Okay. Regular triangular pyramids could be a problem if you got to start, finding height or slant height when you just know one of those things and trying to find the other one. This isn't too bad because they give you the height. They give you the height is 10, and they give you a base edge of 8. All right, I needed the height, which was nice for this, but I also do need to know the area of the base, and that's the hardest part about this. And we do a lot of these, so equilateral triangle. If that's 8, this then would be 4. This would be 4 square root 3 here. So the area of the base is a triangle. It's a half times base times its height. And that's just B. That's just B. And then this is height of the whole thing. This whole thing is B. And yeah, there's a couple things to worry about here because one thing is this little 4 square root 3, this is the height of the triangle. This is the height of the pyramid. They're totally different. We call them both height, but they're totally different places on the thing. The 4 square root 3 is like a segment that goes across here. It's just for finding the area of that triangle. Height of 10 in the pyramid, totally different. So I got sort of 2 different heights here. All right, so this is 16 times 10 would be 160. Square root of 3. And that's it. All right, regular pentagonal pyramid has base edge 6. And a lateral edge is this thing here, which really isn't good for much. It's good for finding other things, but lateral edge is never really in a formula. We either use slant height or we use height of the pyramid. It says find slant height and find lateral area. Well, once I have slant height, this will be easy. Because lateral area is just going to be half PL. Once I know L, it's not too bad. All right, so let's look at one face of this pyramid. It has a, oh, this is a really bad picture because that's 6 and that's 5. Yeah, of course that's 6 and that's 5. All right, so this is on the face. There's L. This is the right triangle if I cut that in half, and this is 3. So I can use the Pythagorean theorem, and I'll find out that L is 4. That's not bad. If I had to find volume on this thing, this would be a pain because this thing would be 4 now. I have to find like the apothem of the pentagon, and I could use Pythagorean theorem to figure that out. And this would be trig, and yeah, it'd be kind of a disaster. All right, half. But since I know L now, I'm good to go on this. Perimeter of the base is 30. It's the pentagon on each 6. And I've got 30 seconds left. And L is 4. So this is like 2 times 30, which is 60. Done. I will see you in part 3.